What's up, scholars? Today on Amazing Science, we're going to be looking at some really cool stuff. Remember I was telling you about my coffee mug, my Keurig? That's not a Keurig. I don't know why I keep calling it a Keurig. It's because the Keurig makes my coffee every morning. This is an imitation Yeti, and my imitation Yeti is a perfect insulator because it keeps my coffee warm all day long. So I can just keep sipping little pieces, and it's always warm going down my belly. I love the fact of the science and how we can use the science of insulators and conductors to help us in our daily lives. I enjoy that we know that these gloves are an insulator and that these insulators can help to protect us whenever we're touching warm things. We're talking about conductors and insulators. Conductors are materials that allow electrical and thermal energy to flow through it easily, and insulators go, they slow the energy down. Yes, they do. So what we're going to be looking at today is we are actually going to look at three materials. We're going to look at a paper cup, a plastic cup, and a foam cup. And what we're going to do is we're going to see what material makes the best insulator. Now, ideally, it will be perfect to have three cups of the exact same size, but I don't have those, so we're going to make do with what we have, and we're going to make sure that the exact same amount of water makes it into each cup to maintain our accuracy. Now, how are we going to determine how much thermal energy is lost? What tool could we use to measure the amount of thermal energy? I know you're thinking, what is the name of that tool that we use to measure thermal energy? Yes, you got it. It is a thermometer. A thermometer is a tool that we use to measure the amount of thermal energy. Now remember, in science, we do not use Fahrenheit, we use Celsius because we are on the metric worldwide language. You all want to speak the same language. So we are going to measure in degrees Celsius. Now what we're going to do is we're going to stick one thermometer in each cup. We are going to cover the cups so that we try to reduce the amount of thermal energy that's lost, and then we are going to fill it with the water. And what I'll do is I will call out the temperature, so we'll actually be able to just see exactly what's happening. Is the temperature staying the same? Is the temperature decreasing? What is happening with the temperature? Is it increasing? Who knows? Let's see what will happen. But here's what you're going to have to think about. Based on what is happening with the temperature, what materials are the best or the worst conductors of thermal energy, okay? Or you could think about it on the other side. You could say, what material is the best insulator? Now, if it's an insulator, what do you think is going to happen to the material? Now, just think about it. With my coffee mug is an awesome insulator. And what happens to my coffee all day long? I called it an awesome insulator. But what happens to my coffee all day long? Why do I like my imitation Yeti? Like, why? Because it keeps my coffee warm all day long. So now take that same knowledge and let's apply it to this to see what material is going to be the best insulator. Now I'm going to use my safety gloves as I am pouring the warm water. And then after we get done with that, I will come right back, throw the thermometers in there, and we are going to make observations about what happens with the temperatures as we are going through this. So I'm thinking we are going to do right there. There's my line. Right there. There's my line. And right there. There's my line. All right. So now that I've got my cups, I'm going to stick my foam in. I'm going to stick my paper in. I'm going to stick my plastic in. And I'm going to come right here. We're going to cover these up so we can make sure that that's not where the thermal energy is going, and we're coming straight in with the thermometers. 1, 2, and 3. All right, now let's make some observations. Okay, so with my paper cup, I instantly see the temperature is flying up. This thermometer is flying up. Right now we are at 81 degrees Celsius. With the plastic, it's flying up as well. The plastic is actually located at 72 degrees Celsius, and my foam is right at 80 degrees Celsius. Okay, So let's observe what happens as we are sitting here and watching. So we have 82, we have 76, and we have 80. Okay, so I noticed that we're pretty much hanging. Nothing's really happening right now. My foam is staying pretty consistent. My plastic seems to be dropping a little bit. That's down to about 74. And my paper seems pretty consistent at 81, 80 degrees. So we've got these are both in the 80s, and this one's dropping down to the 74, 75. Okay, now I want you to think about this. Based on the observations that I'm making, if the temperature is staying the same, the temperature is not dropping, are we going to think that that material is a good insulator, meaning it keeps the heat in? Or is it a good conductor, meaning it's releasing the heat and it's letting it flow through easily? Like, what do you think? What word would be more accurate? And I know there's a lot that goes into this. You could talk about the holes in the top. You could talk about the different cup sizes, but just keep it on the surface. Let's look at the temperature. This is a mostly consistent investigation. How would you classify the materials based on what we observe that is happening with the temperatures? Now, I'm watching my plastic cup is dropping rapidly. My plastic one is down to 70 degrees Celsius now, and my paper one is down below 80, and my foam cup is still, it's right even keel, right there at the 80s. So if I had to make an observation right now, I would say my plastic is dropping the fastest, my paper is second, and my foam is maintaining the temperature the best. It's maintaining the highest temperature for the longest period of time. My foam, my plastic, my paper. Now, what are you thinking? What are your thoughts? What are your thoughts about the foam right now being at 80 degrees Celsius? It started off around 80 and it's still around 80. What do you think about that material? What words would we use to describe it? Would you think you would use the word insulator? Do you think you would use the word conductor, and why? Could you use it in a complete sentence? I think that the foam is a blank insulator or conductor because blank. But you have to be able to give a rationale, you have to be able to give a reason, and it has to be able to be based on evidence. If you don't have evidence, it's not science. It's just speculation. And then we really don't get anywhere at all. All right, so now I see we're at about 75. This one has actually dropped down. My plastic has dropped down to 68, and my paper is down close to 70. So it's about at 72 degrees Celsius. So we have about 72, 65, and then this one is right below 80. All right, so now we have a lot of information. We've had a lot of data. I've given you a lot of data points. We've observed these thermometers, and we see that they're dropping gradually. So we know that thermal energy is being released. How do we know that? Because the temperature on the thermometers is decreasing. That means that the thermal energy is being released. That means it's decreasing. But we also know that the energy is not being released at the same rate. Some materials are releasing energy at a faster rate, and some materials are holding on to that energy and they're releasing it at a slower rate. Now here's what I want you to do. Based on what you've seen, based on what we've talked about, and based on your understanding and knowledge of conductors and insulators, I want you to classify these materials as the best and the worst insulator or conductor of thermal energy. I don't care what way you go with it. Just do whatever your teacher says. If they want you to classify it based on insulation, because this is primarily an insulation investigation, that would be perfect. But if you really want to flip it up and start talking about what one was releasing the most thermal energy, you can do that way as well with the term conductors. Pick your desire. It's up to you. Either way, it's going to be science. Okay, so remember that a conductor is a material that allows thermal and or electrical energy to flow through it easily, but an insulator, it does not allow the energy to flow through it easily. What one of these materials would you consider is the greatest insulator of thermal energy? Have an absolutely wonderful day, scholars. Y'all are amazing. Science is amazing, but it's not amazing without you. What makes science amazing is being able to give it to amazing and awesome scholars like yourself that are literally going to change the world as we know it. Have an absolutely awesome day, and we will be back on soon with more amazing science.